Welcome to Unique Academy YouTube channel. In this video, we will see gate problems from thermodynamics. So question number 1, gas in the cylinder piston device expand from a state P1, V1, T1 to P2, V2, T2 through a polytropic process. So PV power n equal to constant, n not equal to 1. So n not equal to 1. Assuming ideal gas behavior, the expression for the work done by the system. So we know that it is a closed system because cylinder piston device, closed system. So the work transfer in the process 1 to 2 is integral PdV. So from the expression PV power n equal to constant, we can write P equal to C by V power n dV. C V power minus n plus 1 by 1 to 2. So you can write C as P1 V1 power n or P2 V2 power n. So C into, so this will be V2 minus n plus 1 minus V1 minus n plus 1 by maybe 1 minus n. So C you can write P2 V2 power n into V2 power minus n plus 1 P1 V1 power n V1 minus n plus 1 by 1 minus n. So this will give you P2 V2 minus P1 V1 by 1 minus n. So the answer is B is the answer. So this will be your answer. Okay, so now we move to question number 2. So a 1.3 meter cube rigid vessel. So a rigid vessel contains 8 kg of saturated liquid vapor mixture. So the volume is 1.2 meter cube. Mass. So mass is mass of liquid plus mass of gas is 8 kg at a pressure of 150 kPa. That means you have liquid and gas together 8 kg. So this is mass of gas, mass of liquid. So what is the specific enthalpy of this mixture? So specific enthalpy is HF plus X into HFG. So HF and Hg is given at a pressure of 150 kPa. We need X. So what we do, we know that specific volume of this fluid is equal to V by M 1.2 divided by 8. .15 meter cube per kg. So we know that specific volume is equal to Vf plus X into Vfg. So at 150 kPa, you are given Vf and Vg. So we can use that. V is 0.15. So we know that Vfg is equal to Vg minus VF. VF is 0.001053 plus X into Vg minus Vf 1.1594 minus 0.001053. So you get X. So 0.13 is the dryness fraction. So once the dryness fraction is known, then this can be found. HF will be 467.13 plus 0.13 Hg. So because we know that HFG, Hg minus HF, 2693.1 minus 756.51 kilojoule per kilogram. So this will be your answer. 756.51. So we move to next question. So air in a closed system undergoes a thermodynamic process from initial temperature 300 to final temperature. So air in a closed system, that means it may be a kind of a piston cylinder device. So closed system, here the temperature is initially at 300 Kelvin, goes to a final temperature of 400 Kelvin. Specific heat of air, CV. CV is varying with respect to temperature, and it is given in kilojoule per kilogram Kelvin. So change in internal energy. So we know that for an ideal gas, so it is air is an ideal gas. So change in internal energy, du equal to CV dt. So du equal to CV is given as 0.7 plus 0.27 into 10 power 3 T into dt. So now you integrate from 1 to 2. So you will get a change in internal energy. So this you will get in the unit of kilojoule per kilogram Kelvin because CV is in kilojoule per kilogram Kelvin. So this will be the change in internal energy is also we will get in kilojoule per kilogram Kelvin. So this will be equal to 0.7 T plus 0.27 into 10 power minus 3 T squared by 2. So T1 to T2. Maybe you can take it T1 to T2. T1 is 300 Kelvin. T2 is 400 Kelvin. 0.7 into 400 minus 300 plus 0.27 into minus 3 by 2 into 400 squared minus 300 squared. So we just see what we are getting. It's 79.45. Okay, so not Kelvin, kilojoule per kilogram. So now we will move to the next question. So a vertical piston cylinder device. So it is a vertical piston cylinder device. Contains a fixed mass of gas in equilibrium. The cross-sectional area of the piston, so area of the piston, 0.5 meters squared. For 150 kPa pressure of gas in the cylinder, what is the mass of the, so gas inside the, so Pi, which will be inside the pressure, 150 kPa. What is the mass of the piston? So what is the mass of the piston? Atmospheric pressure, P outside atmospheric pressure. So here the pressure is inside pressure, here outside pressure, 100 kPa. Acceleration due to gravity G is 99.81 meter per second squared. So now if you take the balance, force balance for the mass, mg will be acting downward. So the pressure Pi into area of the piston will act upward. The pressure outside will act downward. So these are all the forces. So now we need the mass m. So if you take the force balance on the piston, you will get plus mg equal to Pi into A. So we want mg in kilogram. So this must be substituted in Newton per meter squared. 10 power 3 Pascal. Pascal is Newton per meter squared. So same thing here, 100, 10 power 3 Pascal or Newton per meter squared. P0 is 100 into 10 power 3 area. Area is 0.05 plus m into acceleration due to gravity is 9.81. P inside 150 into 10 power 3 into 0.05. So we get m mass of the piston in kg. Two 54.84 kg. So now we move to question number 5. So a Carnot heat pump extracts heat from a environment 250 Kelvin and supplies 6 kilowatt heat to a room which is maintained at a temperature TH. So TH is the room temperature. Because it is a heat pump, so it takes heat pump. So Carnot heat pump. It takes heat from the atmosphere. Atmosphere is at low temperature, 250 Kelvin. So this is the cold temperature or low temperature, TL. From there, it takes the heat and supplies to a high temperature by taking a work input. QH, 6 kilowatt heat is supplied to the room. So this is the room. So a heat pump supplies heat to the room and maintain the room at a higher temperature than the atmosphere. So QH will be 6 kilowatt. Lot of heat is supplied to the room. The heat pump required a power input of 1 kilowatt for its operation. Then the temperature of the room TH. So we know that this work input will be equal to QH minus Q low. This difference will be, so QH is 6 minus QL. This is 1. So QL will be 5 kilowatt then. So QL is 5 kilowatt. Now since it is a Carnot heat pump, so ratio of heat will be equal to ratio of temperature. This will be valid for a Carnot heat pump. So this will give you the TH. QH is 6, QL is 5, TH is what we want, TL is 250. TH (300 kelvins). So the answer is 300 Kelvin. So thank you for watching this video. If you are happy with this video, please subscribe the channel and share this video to your friends who are preparing for GATE mechanical engineering subject. If you want to join for GATE 2026 video course, please contact in the number displayed. You can also visit the website. Thank you.